My name is Miguel Artuno from Mrs. Kirch's first period class, and this video will be about finding zeros for the fourth degree polynomials. This would be problem 7 from the spreadsheet. So the first step you would want to take would be to use the rational roots theorem to find all possible zeros. This is also known as the P's and Q's. These are the factors of the constant term negative 33. This is the factors for the leading coefficient, which is 5. And this would be the P's and the Q's. Alright, so the next step would be to use Descartes' rule of signs, which would help you see the sign changes of the polynomials. Yeah. So this would be the sign changes for the positive, which is like that, and for the negative, which for the odd numbers, for the odd coefficients, you would have to change the signs. So as you can see, for the positive, there's only one real zero, one positive zero, and for the negative, there are 3 or 1 negative zeros. Now we do this we count by pairs because there could also be imaginary numbers, and imaginary numbers come in pairs. So that's why we count in pairs. So once you have done that, you go on to synthetic division to find the zeros. And you get the zeros from the P's and the Q's, which are these again. So right here is an example of using synthetic division. I used -1 just to test it out, and in the end it worked because the remainder turned out to be a 0. And yeah, so we have 1 0 down. And the next part, or just keep on, well, the next number I used was 5, and as you can see, it turned out that it wasn't a 0 because the remainder wasn't 0. So this would be a bad example. So you continue on, and so I used 1 over 11, a fraction, and in the end it turned out to work because again the remainder was 0. Okay, and this is also used to find to narrow it down to just a polynomial, which would be right here. You get the bottom numbers, and yeah. So the resulting polynomial would be negative 33 x squared plus 11x minus 55. And I factored out an 11 because you could, just to make it easier. So once you have done that, you would either factor out the polynomial, complete the square, or you would use the quadratic formula. In my case, I use the quadratic formula, which is negative b plus or minus radical b squared minus 4ac over 2a. So just plug in the numbers like that. So I reduced it right here, which is -1 plus or minus radical 1 minus 60 over -6. And so yeah, that equals that. And since we can't have a negative as a denominator, I just multiplied the denominator by -1 and did the same to the numerator. And my final answer for the quadratic formula was 1 plus or minus I radical 59 over 6. And we got the I because negative 59 couldn't be couldn't be squared, or excuse me, it can't be square rooted. So we just took out an I, which is for imaginary, and then the answer is 1 plus or minus I radical 59 over 6. So once we have done that, you have found the zeros, which are 1 over 11, negative 1, 1 minus I radical 59 over 6, and 1 plus I radical 59 over 6. And this factors it to 11x minus 1, x plus 1, and negative 3x squared plus x minus 5. So this is solving for 4th degree polynomials and finding the zeros. Thank you guys for watching.